I'd like to spend a little bit of time in this lecture talking about security in the cloud. And, security gets a lot of attention these days because every time you open up the newspaper or look at a security blog, you'll see articles describing major security incidences. And many of those security incidences are related to cloud based resources. That's just due to the fact that many companies are now moving their applications and services into the cloud. And so naturally, we would expect to see more security issues related to those cloud based applications. Deploying security in the cloud is no more challenging than deploying security in an on-premise environment, in some sort of traditional corporate data center. In fact, I would argue that it's easier to secure your applications and services in the cloud than it is on-premise. However, despite the fact that it's probably easier to secure those resources, we still continue to experience challenges. And I wanted to let you know about the different services which are available in AWS to help you mitigate security threats. And I'll also cover some of the biggest challenges that you will face when trying to maintain security in a cloud-based platform like AWS. The first thing to understand is that when you are building out your security architecture in AWS, you are building it around a shared security model. And what does that mean? Well, what it means is that AWS is responsible for some of the cloud security, and you, the customer, are responsible for some of the cloud-based security. AWS is responsible for maintaining the security in their physical data centers, in their physical compute servers, their storage systems, their databases. They are responsible for maintaining the security of their control plane, the sort of the back-end suite of services that are managing the services that they're delivering in AWS. You, as the customer, then are responsible for maintaining the security of the infrastructure that you're building on top of AWS. When you launch an EC2 instance, AWS is responsible for the physical server, but you are responsible for the operating system that is running on that EC2 instance, maintaining the OS, configuring it properly, and patching it with security updates. You are responsible for the application services that you install in that operating system. So if you install something like an Nginx web server, you're responsible for patching that server. If security patches are released by the vendor, when you build your own custom applications and you write your own custom code, you are responsible for making sure that that code doesn't include or doesn't allow for cross-site scripting attacks or SQL injection attacks. You, the customer, are responsible for that layer of security, and that goes across the board. So across all of the different services which are offered in the cloud. So that's something that you just always need to keep in mind. Security is truly a joint effort between you and AWS. In terms of AWS Network Security, AWS is responsible for maintaining the security of its network. Of course, it's got an expansive network architecture that includes routers and switches and other infrastructure components. AWS is responsible for managing those components. And one thing to keep in mind is that the AWS network, the network that we use as customers, is similar to the Amazon network, the network that powers Amazon.com, but they're actually logically separated from one another. So your traffic is not necessarily going on the same network connections as the Amazon.com traffic. Amazon has a number of security, protections in place on its network. For example, it will prevent customers from IP spoofing, which means that you could potentially configure an EC2 instance to send out data with an IP address or a MAC address that is not its own, effectively spoofing some other customer's EC2 instance. AWS does not allow you to do that. AWS has mechanisms in place to prevent that sort of IP spoofing. And oftentimes when you have infrastructure that's running in a data center or in the cloud, you may want to proactively scan that network and scan those resources to understand if there are any vulnerabilities. And you do that using a network port scan. You can't just simply perform a network port scan of your AWS resources. If you do that, then AWS, their monitoring systems will interpret that as an attack and will begin to block you. If you need to perform some penetration testing or some network port scans, then you can contact AWS in advance and get their approval, and then they will allow you to perform some penetration testing of your platform and of your AWS resources. AWS provides a number of different services today that you can use to enhance your platform security. And I'm not going to cover all of the different services which are available, but I'll give you some of the key highlights. And AWS has been investing a lot of effort in this area over the past 3 or 4 years. I remember when I first started using AWS back in 2009, 2010, of course, security was a big concern at the time, but they didn't really offer a lot of managed services in that particular area. And that has completely changed today. Today, there are tons of different security services available, starting with the Web Application Firewall service, or the WAF service. And this is a managed service provided by AWS, and you would use this service to protect your web applications from a number of common attack vectors. For example, bad actors out there that are trying to perform SQL injection attacks or cross-site scripting attacks. Those sort of attacks would be recognized and blocked by a web application firewall. The web application firewall, it sits in front of your web servers, sits in front of maybe your elastic load balancing layer, and it's one of the first infrastructure components that would receive incoming web requests. It would take a look at that web request to sort of see if it's a potentially malicious request, and if it's a malicious request, then it would block it. And it would block requests based on a set of security rules that it's following. You can use some basic sort of template security rules in your WAF, and you can also create your own custom security rules using the WAF web console or the API. The WAF is never really deployed on its own. It's always deployed as part of a group of other resources like a CloudFront distribution or and a load balancer. The next security service I want to take a look at is the AWS Shield Service. The AWS Shield Service is a managed service which you can use to protect your application from distributed denial of service attacks, or what we call DDoS attacks. These are attacks where the attacker is able to compromise or gain access to tens of thousands, hundreds of thousands, even potentially millions of servers or workstations across the internet. And the attacker is able to control those workstations and direct them to send requests to a specific website. And when you have hundreds of thousands or millions of hosts on the internet that are sending these random requests to a website, they're effectively pummeling that site and bringing it to its knees, and generating so much demand that the website is not able to respond to valid requests anymore. These are network layer 3 and 4 attacks. And the AWS Shield Service is able to recognize these distributed the DDoS attacks, and is able to mitigate the impact of those attacks. You can imagine that AWS, is created by Amazon, and Amazon.com has to be able to protect itself against major DDoS attacks on the internet. And they're able to then to sort of extend that umbrella of protection to you and your web application platform. The next service is AWS GuardDuty. And GuardDuty is a security service which is looking at and analyzing log file data that's coming from a number of different AWS services like CloudTrail and your network flow log traffic and your DNS access logs. GuardDuty will analyze the log data that is being continuously generated by these services, and it sifts through that data looking for potential threats. And it can sort of analyze the patterns in that data to determine if somebody is actively trying to hack into your platform. And if it sees a potential threat, it's able to trigger an alert and notify your staff member about anomalies that are occurring within these logs. It's also got the ability, based on an alert, to automatically trigger something like a Lambda function, which we'll talk about later in the course, and use this Lambda function to automatically potentially remediate issues. Like, for example, maybe it would automatically trigger a change in a security group policy or in a WAF rule, and that would actively try to prevent an attacker from hacking into your platform. Very cool service. It's really useful because you can imagine that you have all these different AWS services. They're generating literally millions and millions of log events over time. And it's just simply not possible for a human being, or even a group of human beings, to really look through all these logs effectively, much less in near real time. And so the GuardDuty service is an automated way, it's automated service based around machine learning technologies that can automatically identify potential threats. The AWS Inspector service is kind of similar in some ways to GuardDuty. GuardDuty is looking at logs generated by various AWS services. The Inspector service will actually scan your application hosting environment. So the Inspector service is scanning the network that your application is running on, and it will look at the open ports that are available on that network. And if it sees that the network ports have changed, then it might send you an alert. For example, if a hacker was able to access a server, or and if they access the server and they were able to open up a new service running on that server, running on a unrecognized port, then the Inspector service might flag that for you and send you an alert. The Inspector service can also you can install an agent on your EC2 instances, and the Inspector service can communicate with that agent and scan the actual system packages which are installed on each of your EC2 hosts. It will compare those system packages to the CVE list. The CVE list is the Common Vulnerabilities and Exposures list. So every time there's some sort of security defect that's found in a well-known package, a software package that's published on the CVE list, and the inspector service can determine if that potentially insecure package is installed on one of your EC2 hosts. The inspector can also look at your operating system configuration and compare it to the CIS benchmarks. That's the Center for Internet Security Benchmarks. And that can tell you if there's some sort of misconfiguration or vulnerability in your current operating system configuration. And finally, it can look at the sort of general security configuration of your host, and it can compare your EC2 instance security configuration to best practices. For example, you might have an instance where you haven't disabled the root user, and you're allowing the root user to log in via SSH. That's generally a bad practice, and the inspector can help you find if a server's been misconfigured. And more importantly, the inspector is sort of continuously inspecting the security configuration of your hosts. And if an attacker was able to compromise a certain host and change the security settings, then the inspector service may be able to detect and alert you regarding that particular change. The AWS Certificate Manager service allows you to go out and generate SSL and TLS certificates, which you can then use with your AWS services. For example, if you were setting up an Elastic Load Balancer and you wanted to set up SSL termination on that load balancer to allow your customers to access a website using SSL and TLS, if you wanted to do that, you need to install an SSL TLS certificate on the Elastic Load Balancer. Now, in the past, traditionally, in order to generate a certificate, you had to go out and purchase a certificate from a certificate authority, and there were dozens of different certificate authorities out there on the internet, companies like Thought and others, and you'd have to pay hundreds of dollars to purchase a certificate, and the certificate would expire after a year. So you'd spend hundreds and hundreds of dollars every year buying these certificates. Well, you can generate certificates for free, essentially, from AWS, and then use those certificates on different AWS services like the Elastic Load Balancer and CloudFront distributions, and use them with the API gateway. So it's a great service because it saves you a lot of money from having to go out and buy certificates from third parties. Now, the only caveat is that you can only use these SSL TLS certificates with AWS services. You can't actually take this certificate and install it on something like an Nginx or Apache web server. If you wanted to set up a certificate in your own application, then you would need to go out and buy that certificate from a third party. You can't use the AWS Certificate Manager for that particular use case. The AWS Key Management Service is a really important security service within AWS, and it's not something that we'll use all that much in this course, at least not directly, but it's something I want you to be aware of, because you might see, as you're configuring services, you might see references to KMS. And essentially, the KMS service allows you to create encryption keys. And you can use these encryption keys with a variety of different AWS services. I don't want you to confuse this with the previous service I just talked about, the Certificate Manager service, where we are creating SSL TLS certificates, and those are specifically used with web browsers. The Key Management Service lets you create keys which are used for basically everything else, a variety of other AWS services. So for example, you would use the KMS service to create encryption keys for S3 buckets, or to encrypt your AMIs, or even to encrypt your database data. When you spin up an RDS instance, you can encrypt the data on the RDS instance using a KMS key. This is just simply an encryption key which you, the customer, can own and manage. And one of the advantages of these KMS keys is that you can create multiple keys for different purposes, and then you can control who has access to the encryption keys. So you might have multiple teams within your organization with multiple services, and each team could have their own separate set of keys for the services that they maintain and manage. So it's a way to not only encrypt the data within each managed service, but it's also a way to control who has access to the actual data by giving certain people access to certain keys. Now, there are a whole ton of different security services which are available within AWS, and each security service is generating alerts, and it's generating metrics. So the question is, how do you sort of collect all of this security information together? Well, you can do that using the AWS Security Hub service. And this, at the time that this video was created, the Security Hub is a relatively new service created within the last year. It essentially provides you with a comprehensive view of all of the different security alerts and the compliance issues that are occurring across all of your different AWS accounts. It's that single portal, that single hub that collects all the telemetry information and alerts from the various security systems which you have enabled in your accounts. And it's very similar to what we call a SIEM, which is a Security Information and Event Management System. It's the centralized security hub. And many organizations have these sorts of security hubs in place with their traditional infrastructure. The SIEM will collect information from all kinds of different AWS services, including all the ones that we've mentioned in this lecture. Things like GuardDuty, the Inspector service. There's a service called Macy, which is looking at the data in your S3 buckets. And there are a host of different third-party AWS partners which also integrate into this Security Hub service. The last thing I want to cover in this portion of the lecture is I want to cover the top 5 cloud security issues that I see occurring within the marketplace. And these are based upon not only my own personal experience, but the blog articles and the security thought leaders out there. They're constantly talking about these particular issues. I also, somewhat in jest, say that these are the security issues that are going to cause your CEO to get fired. These are the blatant security issues that companies sort of fail on. And when companies fail in any one of these areas, it usually causes a huge problem for the business, and in many cases, the CEOs and their senior IT leaders have lost their jobs because of it. So let's start out with the top 5. We'll start out with the first one, which is stolen access credentials is a major security issue. You might be using a username and password to log into the AWS web console. It's relatively easy to steal those credentials. If somebody were to install a keylogger on your workstation, then they could easily steal those credentials and then gain access to your AWS account. Well, one of the ways to mitigate that is to make sure that you have enabled multi-factor authentication on your account. And that's a must-have, especially in a corporate environment, production environment. You would absolutely always want to enable some form of multi-factor authentication for all of your accounts. It's a must-have security configuration. The second security issue that I see is, and this is very common, unfortunately, is compromised access keys. You might use your username and password to log into the AWS web console, but if you are building an application that needs to programmatically access the AWS API or access data and services like AWS S3, then you would use API access keys to access those resources. We haven't used access keys much in the course, but we'll begin to use them more as time goes on. The access keys are associated with a user account, and depending on the sort of the role or group that user account is associated with, the access keys could provide very powerful access to your AWS account. And what oftentimes happens is that software developers in particular will use these access keys as part of the configuration for the application. So you might, the application might be coded and designed so that it can access data in S3 buckets. Well, in order to do that, the application needs to have a set of access keys in order to programmatically access the AWS S3 service. Well, what happens oftentimes is that developers will embed those access keys. They'll hard code the access keys into the application source code. And then they will commit that code to a repository, and it'll end up either in the corporate private Git server or even in GitHub somewhere. We've even seen these keys end up in open source projects where people just inadvertently will commit and publish their access keys on the internet. And once your access keys are published on the internet somewhere, then it's only a matter of time before the bad guys find them. I was working with a client a year or two ago, and one of the engineers was trying to troubleshoot a problem in some configuration management code. This, I think, was some Ansible code. And the engineer had been doing some testing work, and as part of that testing, he had hard-coded in the access keys into the script code. And he posted a block of code on, I think it was he posted the code on the internet somewhere on a troubleshooting site, and maybe on Slashdot, but the result was that he had inadvertently published those access keys without even really realizing it. And we didn't even know he had done it either until 3 months later. We woke up one morning and found that somebody had launched hundreds of EC2 instances in one of our accounts, and those instances were running a Bitcoin mining software package. So somebody was stealing CPU from us and using it to try to find Bitcoins. And over the course of a few hours, ran up a tab of about $7,000. So that situation could have been much, much worse. And that engineer was dismissed from the company. They lost their job essentially because they had inadvertently exposed these access keys. The third security issue is related to S3 buckets, and this is such a constant problem, and I think it's just due to a lack of education. And I'm glad that all of you are taking this course because you will have a much better understanding of how to configure S3 and secure it properly. But people who are sort of new to AWS, new to the cloud, new to working with S3, they're configuring it and inadvertently making their S3 buckets publicly available. And what will happen if you make your S3 bucket publicly available is that eventually somebody's going to find it, and somebody's going to be able to download the data that's in your S3 bucket. And over the years, people have found unbelievable data sets in public S3 buckets, data sets containing order information and people's credit card information and social security numbers and birth dates and so on. And there are a multitude of ways to mitigate that sort of threat. You can use the AWS config service, which we'll talk about later in the course, to monitor your account and look for potentially vulnerable public S3 buckets. You can use third-party security scanning tools like ThreatStack to also alert you if there are S3 buckets that are publicly available. It used to be, like years and years ago, it used to be easier to inadvertently make a bucket publicly available. But today, you really have to go out of your way. You have to really be almost incompetent, I think, in a way to deploy an S3 bucket which is publicly available, because AWS puts so many checks in place to really prevent that today that it almost has to be purposeful in order for it to happen. The fourth cloud security issue revolves around security group rules. And the security groups, of course, are that sort of firewall layer of protection around our EC2 instances and our databases. And they define what communications are allowed in and out. And what I'll oftentimes see is I'll see inexperienced engineers creating security groups that have really, really permissive rules. Like they'll create a security group which will allow all incoming and outgoing traffic, which is a really bad idea. Your security group should be designed so that it's only allowing the required protocols and ports to access your server, and it's only allowing the minimum set of egress ports and communications as well. Why do people create overly permissive security group rules? Well, generally because I'd say they probably just lack the understanding and education around how to properly create security groups. And also what I'll find is that sometimes application developers, they're trying to troubleshoot some sort of networking related problem, and it might be related to the security group. And so what they'll do is they'll make the security group really, really permissive, like allow all traffic from like everywhere. And that will fix whatever application communication problem they're seeing. And they'll forget to go back and tighten up the security group rule and to really understand how to what minimum rules are required. And so And so, sometimes these permissive security group rules are just a result of just bad troubleshooting or sort of lazy behavior on the part of engineers. And the last cloud security issue that I want to talk about are the improperly scoped IAM roles and policies, which is somewhat related to security group rules, in the sense that I oftentimes see people and engineers creating overly permissive security roles and policies. The worst case would be that somebody would create a role that's associated with like an EC2 instance or given to an application service with something like admin access to everything, to all resources within the account. We should never ever see a role or policy set up like that. The IAM role or policy should be very carefully scoped so that the service which is being granted that role is being given the minimum set of actions necessary to accomplish a particular task. And it's only able to perform those actions against a narrowly defined set of AWS resources. Again, oftentimes what I'll see happen is like application developers who just don't have much AWS experience, and they're really just trying to write code and get the application working, and they see like AWS security as being sort of a barrier to making that happen, and so they'll just create a really permissive security rule because they're more focused on getting their code working versus making sure that it's actually a secure architecture. And so as sort of cloud engineers and architects, we need to spend a lot of time focusing on making sure that the rules and policies we're creating are properly scoped and are very secure.